Hello friends, welcome to my fourth tutorial. It is in continuation of tutorial number 3 where I showed you how to do NVT simulations using VMD and NAMD. Now I will tell you in this tutorial how to plot the graph using the data generated by NVT simulations. So I myself Pratibha Shrivastava welcoming all of you to join this tutorial. I am trying to make as simple as possible. So for plotting the graph, you have to three informations. You have to have three information. One is the DAT file. Second, the software that is called XMGRACE, and you will obtain the Rmsd value which are required. Okay. So how to generate Rmsd value, that also I will tell you. So before going to that, I would like to thank my friend Miss Manisha Kharade from Engineering Unit of Max Agarkar Research Institute, Pune. Whatever computational knowledge I have today for running Linux, she has given me all the training, I must say, because she told me the command simple that how to do that, and that's why I'm able to give you the tutorials and all that. So now I will tell you how to go to the first of all I will start from there where I have ended in the tutorial number 3. So this is the window where I have done this simulations of 5K CV with RUGCL. So this is the end of the simulations, and after that what I have to do, we have to go back to VMD just by writing VMD. So it has started. This is VMD window has opened. Here again we have to go to extension TK console. Okay, so you can do simple command pwd. It will tell you the print working directory means in which directory you are there. Now I have to do ls, so that files which are available over there. Now you can see that in the display there is nothing like that you can visualize, but then I will give the same command more new. Okay, ionized tab.psf. okay, it will add this one, but you cannot see anything. So now I will add dcd file, which you could see it here that I have generated my output.dc, sorry, my output.dcd. This is the file. Okay, so that you have to load it together. More add file. Okay, my output dot dcd. Okay, so this is the file. When it will be uploaded, you could see this one. Now with the help of this, you could see that I will drop down it. Here are the 55 frames. How you can do this? You can just by doing this one, right? This cursor you can move. You can see different frames are moving from here to there. These are the frames generated due to the 5000 steps of simulations, which is very small because it is hardly simply to the 1000 picosecond or something, and papers or publication required 50 nanosecond simulations. So that I could not show you because it takes long time to run all this. Now how to plot the graph or how to get this value. So I will go for this analysis, extension analysis. Here is the RMSD trajectory tool. Okay, so when you go to the RMSD trajectory tool, here is the option which is written over here, that is the protein. You have to select backbone, you have to select plot, you have to select transient. I will do one thing only, I will do file name 2, which is already there. So now first you have to do align. Okay, so when you will align, and after that alignment you have to do RMSD. So this is the graph which is already plotted for this one. So this is the plot which you could see from this 55 frames generated over here, and it is, since it is too bigger and all that, it is multi-plot software inbuilt in the NAMD or VMD software. I must say VMD software. So I will minimize it first. Okay. Now here you can do this right. So this is, I will increase it for better visualization. Okay. So here you can see that this is the average value of Rmsd. This is standard deviation of 0.161, and this is minimum 0.103, and this is maximum 0.799, and total number of frames are 54. Okay. See, these are the important value which you can write in your publications, that this is the Rmsd value of average of your complex generated through NVT simulations. Now I will close this window and then I will tell you how to plot using XMGRACE. Okay. So for that I will go to this Linux C command window or terminal. Now I will open another window. I will just close it. Okay. So I will open another window. Okay. From here I will go to XMGRACE. Okay. XMGRACE. Okay. So the plot has opened, but before doing that, few things you have to do, which I will tell you, because that will save you for the problems arises if you are not doing some kind of slight changes in your file. So here I could see, yeah, this is the file which I have generated, this one, right? Okay. So this is the simple dat file like that you get for the notepad or in Windows, and here it is due to the text editor. So these are the two columns. So first remove these two columns, this one, because it will create problem. And okay, and here you write 0, okay, sorry, 0, and save this file. Okay. So this one. Okay. So now I will do save this file, right? So this is the saved file. Now in the XMGRACE, I think I have opened in the back side. This is the let me see if it is there. Okay. See, this is a window which is open. I will enlarge it, and now from here go to the data. Okay. No, sorry, plot or data. Here import. Okay, in the data, in the fourth line there is import. Go to ASCII2, and then again at the bottom you have to go to the folder which is already there. So if you will open this XMGRACE with the C line command in the same folder, so you don't have to make too much efforts, your file automatically will open. Okay, otherwise you have to face like this. See here. So this is the means has generated. Now I will see it here. Okay. So this is the frame. Okay. So this is the frame which is generated. What you can do, how to add on this one or change the parameters, that also I can see you. Plot appearance, we have to go graph appearance. Here we can put like our 5kcv complex, okay, complex with complex with RUGCL, which is our legend. Here you can write NVT Simulations, okay, and then you say x-axis, x minimum. You can do this by changing x maximum or y maximum. I would like to change little bit, 1.0. Okay, apply. So then you can see, sorry, something I have done wrong. Y max, y minimum is little bit 1.0.85, which was previously. Okay, apply. So this is this one. then I will close it. How to put, oh sorry, instead of I pressed it with the help of shift plus 5. So that's why it is percentage. You can change it and let me do that graph appearance. Instead of this percentage, I can correct it by KCV. Okay. So apply. Then what you have to do, plot axis title. Okay. In the axis title for the x-axis, we have to write time in nanosecond, nano, and you can simply write ns. Okay, and apply. And you can see that minor spacing, minor text 1, and this is 0. Okay, then apply. Fine. So this is simply the graph which is for having only 54 frames. When you will run the longer simulations, then the number of frames how much increase due to the simulation, then you will get the zigzag graph like in the publications which people use to produce. Again, I will show you plot and axis title. Okay, so I will select it Y, and what is the title? Rmsd, which we have obtained via the NVT simulations. Okay, so is minor spacing to major things. Okay, then here you can write if possible from 0 to 1.0. If I will see is then we can apply. Okay, right, then close. Okay, so this is the kind of so many things. Now how to increase the this one. So yes, here in the line spacing, this is the symbol properties. Here line properties, you can say right like this. You can increase the width by 2.5, and you can change the color by red. Okay, and then style you can see. Okay, fine, and then apply. Okay, you could see that the graph style has also changed, and if you do 50 nanosecond scale or something like that, then this will come like this. Use zigzag, zigzag, zigzag. So this is how you can plot the graph for this one. For that, the how to increase the number of frames in the simulation, that information I can give you right now. This is the file where this is the NVT conf file which we have prepared. So these are the things like restart frequency, DCD frequency, XST frequency. It helps you to generate the number of frames. So the number says 5 for 5,000 steps. I have given 100 value of these. If you will give 50,000, then you will get more than 100 frames. If you will again increase 5,000 to 5 lakhs, the number of frames will be increased as much as like 1,000, 10,000 or whatever it is. So you will get that feeling of this one. And XMGRACE is acceptable to all the publication styles. Okay, so this is all about how to plot the graph of NVT simulations. And for NPT simulations, same thing, like you have to prepare npt.conf file. For slight modifications are required, which you can get from the tutorial site or details in the VMD tutorial or NAMD tutorial, which are available. You can modify, and if you need that I should provide an idea how to do NPT simulation, please let me know by subscribing in my channel or in the video, as well as you can write a comment at the bottom. So I will make the video for that also, that how to do NPT simulations. Okay, so this is all about for today's tutorial. Next tutorial I will tell you how to do Ember, and how you can do simulations using Embers, and simple things which are very minute, which will help you to do your simulations. Okay, thank you very much for watching my channel, and please wait for the next tutorial in which I will represent how to use Amber. Thank you very much, and please subscribe to my channel and write your